All right. Hello. Hi. Yeah, nice seeing everyone again. So I think the grades for ESC 180 are posted as far as I know. The way the process works, I think this is the first lecture that you have back, right? Because today is test period or something. So the way it works is you get the grades. The grades are then approved by the undergraduate assessment committee. They have not been approved yet. They have been posted and pre-approved. Once I get word that they have been pre-approved, I will release the exams, at which point you can request regrades if anything's wrong, stuff like that. So that's that. So the course website is going to be, the new one is going to be up later today. For now, I'm just using like ESC190 week 1 from the 180 website. And we'll do that. So the plan for today is to just talk about a little bit from 190 and then to get back and talk about 180 since that stuff is still relevant. Do you hear anything I'm saying? What? Okay, it's just quiet. Okay. So that's like that. Yeah, so one more thing. So labs start next week. This week we don't have labs. So welcome ESC190. So unlike many of the other classes, this is basically the same class as ESC180, just more so. So we will introduce the C programming language. We still need everything from ESC180. So we will review everything from ESC180 as needed, including the exam. So in particular, the first several questions on the exam were done well. Some of the later ones, maybe not as much. So I do want to review all the questions from the exam. And there will be stuff that's not exactly like, obviously, the questions from 180, but we will continue having, recursion, complexity analysis. Memory model actually is one of the more challenging aspects of ESC 180 traditionally. And one reason that we teach it in 180 is that it's even more necessary in 190. So we'll definitely come back to that. So I want to jump right in and start talking about the C programming language. So that's basically what we're going to be using about 60% of the time in this class. So before I talk about C specifically, I want to talk about compiled versus interpreted languages. So Python is what's called an interpreted language. So what that means is that there is a program. So Paizo, for most of you, is the program that you're using. It's a program that takes in Python code and then executes it, right? So that's what's called the Python interpreter. So we actually have seen, if you remember exec from last semester, we've seen like a Python interpreter that's inside the Python interpreter, right? That's exec. So to remind people. So we could say something like, exec, whatever, print hi, and then run this, and this by itself would execute the code for print hi and produce the output. So in a way, the exec function inside Python is a Python interpreter that's built into the Python interpreter itself. So an alternative to that, to Python, is what's called compiled languages. So a compiled language basically takes something that's like Python and translates it into something that the hardware can actually run directly. So inside the computer, there is this thing called the CPU, the central processing unit, which can take very simple instructions. So instructions on the form, move data from address 1032 to address 1064, and it can execute those. So those kinds of instructions, so like, take whatever is at address 1032, literally 1032, and move it to literally 1064. Those kinds of instructions are referred to as machine code. And that's the kind of thing that the computer can actually do directly. So you could imagine actually like wiring it up so that it does it. in a way that you can't imagine probably taking Python code and just arranging the wires on the computer just so that whatever Python code you have in mind actually gets executed, right? So in other words, what the compiler does, again, it's a program, well, the same way an interpreter is a program. And what it does is it takes something that's human readable, approximately, and it translates it into machine code, so something that the hardware can actually execute directly. You will be talking about how hardware actually works in second year. So right now, this sounds probably a little bit abstract because, you know, if you sit in a room, you probably couldn't like wire up a computer to even execute print high. That's actually difficult, but that's about what it is. So in general, machine code is faster to execute than interpreting something like Python. So if you translate things to those kinds of instructions, then running those instructions is faster. The downside is you have to compile. So something that's kind of similar but distinct from what I was talking about is low-level versus high-level programming languages. So high-level languages, like, for example, Python, are more abstract. So what we mean by more abstract is you can say something like for I in range, you know, from this is actually wrong, from 0 to 100 in steps of 2, right? And we hopefully kind of know what it means, right? So it means, you know, make I be 0 and then make I be 2 and so on, right? But that doesn't directly relate to what's going on in the hardware in the computer. You know, eventually somewhere the numbers 0 to 4 are computed. And if you print I, eventually the pixels that correspond to those numbers are going to be displayed, but that's not a direct process. Another example of abstraction is functions, right? So in Python, you can say something like, you know, f of x return x squared, right? And it means that if you plug in 5, you'll get 5 squared. Again, that's an abstraction in the sense that you could translate it to something that's going on mechanically in the hardware, but it's not straightforward. So a higher level language is going to have more such abstractions. A lower level language, C is an example of a low level language, is going to have fewer. So C is still a human readable language. It still is going to have abstractions, just not as many. And the reason is basically the more abstractions you, or at least kind of the connection is that the more abstractions you have, the harder it is to translate it directly into machine code, right? It just makes sense because kind of machine code is like very concrete, like, you know, you have this current here, you want it to affect this thing in the memory here. So the more abstractions you have, the harder it is to compile. Still possible, just harder. Yes. What's the definition of abstract? I doubt I could come up with a good one on the spot other than giving examples. But something like removed from, well, anything that's not concrete. You've taken Civ 102, you know about concrete, right? So something concrete in this context would be you know, having to do with the mechanism of how the computation is done inside the computer. Abstract is anything that's removed from the concrete. How about that? Not going to do better. Just look at the examples. All right. Okay. Okay. So low level languages, again, less abstractions. Okay. So again, Python, high level language, interpreted language. C is lower level, still not the lowest possible level, meaning that instructions in C are not going to be concrete in the sense of they're not going to directly say, like the voltage was low here, so make it high there. C is compiled. Although traditionally compiled, you can make an interpreter for C, so you can make something like exec in Python for C. It's just that people don't ordinarily do it. C code can be much faster than Python code, can be slower to write. Okay, so we'll start other questions. Yeah. All right. So I want to start talking a little bit about C. So we are going to be using VS Code for C, but installing it on laptops is unfortunately a bit of a pain. So that's going to be a bit of a process. I'll post instructions. Hopefully by next week, everyone will have VS Code. For now, we're just doing pythontutor.com. Okay, so I'll switch to Python tutor in a second. So unlike in Python, every variable in C needs to be declared. So what we mean by declare is we need to pre-specify what type of data is stored in the variable. So the types of data that we'll see initially are going to be integer. So double is what corresponds to float in Python. So stands for double precision floating point. We have char. So char is a character. So unlike a Python string, that's a single character, like for example, the @ sign or the letter B. We have a variable that stores addresses of ints, and we have a variable that stores a type rather that stores addresses of char. So those are the types. So the type here is int star. So okay, so let's switch to Python tutor. So I'm over here, and I'm going to see here, and I'm editing the code over here. So this is declaring the variable n, and I'll go through the components of everything in a second as well, but we need to start somewhere. And this is setting several different. So Python was basically designed to be kind of like C. We are learning it in the opposite order in terms of the history of what was developed when. So C would be developed, around the 70s. Python would be more like the 90s. But there is a lot of similarities. There is some differences. So what you see here is you have a function. And we'll talk. So we got to start somewhere, and you have to have a main function in C. So that's going to be in the slides as well. And it returns a value of type int. So that's this part. And doesn't take any parameters. So that's this part. So unlike in Python, indentation is optional. So even though the body of the function main right now is indented, that's just to be nice. What really indicates the body of the function is the curly braces. So here we promised that the function would return something. So this is saying the function is named name and the return type is int. So here we're going to return 0. So one more thing that you'll notice is that every statement must end with a semicolon. Currently, none of this does anything, right? So we just said n equals 25, return 0. We didn't do anything with the 25. Then print the 25. So printing in C is a little bit more difficult. So if I want to print an integer, this is how I would do it. And again, we'll do more of this later. We got to start somewhere. So this is going to print 25. So I'll just visualize this. All right. So what happens when you run a C program is that main is a special function. The main function is always going to be called. So n has to be an int. So you'll notice that in the Python tutor visualization here, it says n is a variable and it has to be of type int. Right now, it wasn't initialized. So here we're initializing it. We're saying n is equal to 25. So now n is 25. Now we're going to print it. So that's in the output here. Return 0 doesn't really do anything. So main, again, is a special function. That's the function that always gets called. Make sense? Okay. Question so far? Yeah. Okay, so the question was, if the return 0 doesn't really do anything, is there a point to doing it at all? The answer is kind of no, you don't have to do it. It would be returned by default anyway. So we are not going to be using it in this class, but what happens is that the value that main returns, technically, if you call this program from outside, which we're not doing in Python tutor, it will return the 0 or whatever else you return to the operating system. And then so 0 means success. Anything that's not 0 is like a code for what kind of error it is. So the operating system might sometimes use this kind of thing. We are not going to be using it in this class. So the reason we're writing it like that is just that with some compilers, if you say int main and you don't return 0, you'll get the warning. It will return 0, but you'll get the warning that you're doing something implicitly. And if you say not int, you can also do that, but again, you'll get the warning. So it's more tradition than anything else at this point. Yes, over there. We'll get to the printf later. Yeah.
So you say like int n. Do you need to say n equals 25 on the next line, or can you do that like 2 lines down?
I can I can do it at any point. It would be better actually if I do it on adjacent lines to say int n equals 25. I just wanted to separate it because I want to conceptually separate declaration and initialization. If I declare int n and I don't say what the initial value is, obviously I cannot use it because I didn't say what the value is. Yes. Does the main function have to return at the end? Again, so C can allow deviations. It's supposed to return an end, however. Yeah.
You put the return 0 over the printf function, would it still print it?
It would not. So the question was, so just like in Python, return means that's the last thing that happens in the function. Yeah. That's just Python. So the question was, do we need to write def? The answer is no. So we wrote int, and int indicates that's the type of thing that the function returns. So because in C, you need to specify the type that the function returns that basically functions as the here comes the function of C. Okay, yeah. What does? So this is just so that they can use printf. Again, I want to kind of, I'm happy to answer all the questions, but they are actually answered later on in the slides. So we just got to start somewhere with a program. Yeah, other questions? Okay, all right, there's a lot to talk on Discord. Okay, so do interpreters just do surface level? That's an interesting question. So interpreters, in some sense, interpret into machine code in the sense that, well, like interpreters are themselves machine code. So think about so here's like the simplest possible interpreter you can imagine for a very simple language. That's print in Python, right? So all it does is it takes a string and it prints it to the screen, right? So that's a programming language. That programming language just consists of it'll output whatever you tell it to. For example, hi, right? So it's much more restricted than Python is as a programming language. All you can do is tell it what to print, right? But that's in a way an interpreter. So the print itself, behind the scenes, what it does is there is machine language that corresponds to it, but it's not that it translates the hi into machine language directly. It's more that the hi is like the input to the print function. In the same way, you can input something to the exec function and it'll execute the Python code. So it's still the case that the Python code that you're inputting into the exec is just the input. It's not exactly that it gets directly translated to machine code in the same sense that the C compiler would. Make sense? All right. So other questions? Return one car and an int. So there is a way to do it in C, but we'll do that later. So you would do kind of struct. That we'll explain later. Okay, yeah. So printf will have like a separate thing about what. I need to teach you about strings in order for you to understand how printf works. But in order for you to know about strings, you need to know about addresses. So here we are talking about addresses. So C does not have a string type the way that Python has objects that are of type string. So instead, what C does is it just puts a bunch of characters in memory. And then it has a special, what's called null character that indicates that the string is over. So the way you would represent the string high is you would say, I have those characters starting from address, for example, 1032, and then the string is just all the characters up to the special null character. Make sense? So how do we store this thing? Well, we'll store the 1032 and we'll tell C, okay, like that's my string. All right. So one way that you can write this, and again, like we're introducing it, we'll do much more of it as well, is I can say car S is ABC like so. And what this means is S is the address where A is. And then S plus 1 is the address where B is. And then S plus 2 is the address where C is. And then S plus 3 is the address where the null. So this would be just the \0 inside single quotes. All right. So when we're saying this, really we mean this. In the same way as in Python, you would have to put this somewhere in memory. So C would decide where it would put the A exactly. And then B and C would be just put, after A would be B, after B would be C, after C would be the null character. And that's how it's going to be stored. So let's execute it and see how it goes. So this is what that looks like. I want the addresses. And what you get is S is okay, so it writes the addresses in hexadecimal, which is not how I do it, but that's okay. So S is this address, which is written like that, doesn't matter. And then the string itself is stored like this, where you have A and B and C in addresses that follow each other. And then you have the null character that's terminating the string. The reason you need the null character that's terminating the string is if you're printing a string, for example, you need to know where to stop, right? We are not storing the length of the string explicitly. We're just storing characters one by one, and then we're storing the null that indicates that the string is over. Okay. Does that make sense? Questions? Yeah. So specifically with strings, this is basically shorthand for put a string in memory, which means put A and B and C and then a null at the end. So that's specifically for strings. And specifically, so it's not really strings, it's more that this is a shorthand for do this. So A and B and C and then a null. Yeah. It finds some. So the question was, where is the character stored? And the answer is it finds just like with Python, it finds some place that's free in memory. Yeah.
Star and char, we never actually specify the address.
We do not. So here and it's a little bit vague because like it's the operating system that's depending on exactly how you do it. But basically what we're saying is ABC with the null is going to be put somewhere, and then S is going to be the address where the A is stored. Make sense? So we're going to have a different way of allocating memory later on, but with both ways, the ABC, it's going to be somewhere, and what we're saying is put the address of the A, or in other words, the address where the string starts in the variable S. The variable S is of type char star. Yeah. Yeah, so that's an interesting question. So the question was, how would you modify a string? The answer is you are not always able to. So just like in Python, if you do it this way, it's actually immutable. So you cannot modify it, even though it kind of looks like you could. We'll see later on that in some context you can. Okay, yeah. Sorry, is the well, so right now we haven't right now we haven't done anything. Whether it prints or not depends on what exactly it is that you do. So if we want to just print S, so if we print it like this, what's going to happen is it will print ABC. It will not print the null character, because the null is just, it's not doing it. Its job is to say that the string is over. On the other hand, this is going a little bit ahead. If you say this, and then you say S at 3, that will print it now. So this is jumping a little bit ahead just to answer your question. So again, we got to start somewhere, and I promise that if not today, then on Wednesday, we're going to have at least like one round where you understand all the code. Right now, we're just talking about, okay, here's how you store strings. Okay. So, all right. And that's again just actually related to your question from before. Can you modify that string? Well, that particular string, no, you could not. It was actually immutable. In C terms, it was really a const char, but we'll talk about it later. So right now, I want to talk about literals. This is an answer to the question from here somewhere. So literals, what are they? They're data that is inputted directly into the code. So something like strings and double quotes, something like integers and doubles, stuff like that. Right? In particular, one example of a literal is strings in double quotes. So they are actually of type address of char, and more specifically const char. We'll talk about it later. So in particular, kind of what happens here should be kind of intuitive, right? So we're saying n is equal to 25. And what that means is take this literal 25 and put it in the variable n. What's going on here is the same kind of thing. So this is somewhere in memory, meaning somewhere in memory, there is A, B, C null. And then what we're doing is in the variable S, which is of type char star, we're going to put the address of the A. Okay, does that make sense? So that was probably, so I introduced a lot of terminology because I kind of had to, but this was like the first conceptually difficult thing, right? So what this means is so S is a variable of type char star. It's written traditionally like this. Some people prefer to write it like this, which is also fine. It's of type char star, like so. And what we're doing is S is the address of the A. Is that not clear to someone? Because usually when I give a midterm, it's not. So I'll just show it again. So one way to look at it is, so we have those different boxes that correspond to different variables. We'll contrast this with Python later on. You'll notice that this is not the same as Python. We don't have a variable table here, right? We just have, boxes that correspond to variables. That's a real difference. But in a way that's more intuitive. So we have the C box, and that has the @ sign. And then we have PA. So PA is of type int star, and we initialize it with 0. And now what's going to happen is S gets initialized with whatever is the address of the A. So this is the address of the A, and this is here. Okay, so S is just a number. Yeah.
Create a variable of type int star or char star.
Mhm.
Does it also create an int and a char as well?
No. So the question was, when I say something like int star PA, is there an int somewhere? The answer is no, there is not.
So say it equals 0, that's just it's holding the address of 0.
Yes, it's holding the address, which happens to be 0. Yeah. And so not the address of 0, it's the address, like literally like 0 St. George Street. Yeah.
0 is just the address that you pulled up.
Yeah, it's not a valid address, but it's an address, right? So we just like PA, just like N stores 25, PA stores 0. The difference is that N is a general type of integer, whereas PA is of type int star, which means it's still a number, but it's a number that we interpret as an address. The value of that address is 0, just meaning like 0 St. George Street. Yes.
There are value associated.
No, there's not. It's not a valid address. Well, it's not. There's not like empty addresses. So 0 is a special one where it's never a valid address. In general, you just pick any number. It's not generally going to be a valid address. Yeah.
Like with an address, and then characters are stored at an address. Why is there?
No. So that's a good distinction. So everything is stored like this, right? Meaning, you have the variable N, you have the variable C, the variable PA, the variable S. Those are all symmetric, right? So in the sense that those are all numbers, they just happen to be different numbers. Now, S happens to correspond to an address somewhere else in the memory table where the string is stored. Right? So really, the storing of the string happens on the right-hand side. In the same way that in Python, you have something in quotes, that gets put into memory. And then what's on the left-hand side here is just the address of the A. Make sense? So, okay. I promised that we will get to the printf. So the way the printf works, and that's also going to be on the slides, is we have basically a substitution. So here, what I'm saying is substitute %s with this string s and print that. So that's why that prints ABC. And now here I'm saying take asset 3, and this happens to be the thing at s+3, which we haven't done yet. And I'm saying interpret it as a character. So again, that's going to be later on officially in the slides as well. And that's just like in response to the question. So here it prints like whatever it is that it thinks a null looks like. Okay. So why is it that it works like that? Well, it kind of has to, because this is a number. It happens to be an address, right? So when I say print this, I don't want to say I want to print the address. I want to say I want to print the string that starts at that address. So the %s says, take this number, interpret it as an address, and then print, you know, the first character, second character, third character, up until the null. So that's what the %s says, is take this number and interpret it as the address of the first character of a string. This is saying take this number and interpret it as just one character, print that. Yeah.
So a couple questions. One, why would you use like the %d for the number up there for n?
Yeah, so similar. So D stands for decimal. So this says take this number and interpret it as a decimal number and print that. Yeah. Again, that's also going to be on the slides. Yeah. Yeah. So S stores the address of A. So you'll notice that this is the same as this. Well, the answer is it has a loop, right? So it says, you know, and we'll implement it later on as well. So it says like, I'll go to the address S, and if it's null, then I'll stop. If it's not null, then I'll print whatever's here. And then I'll go to the next address and I'll print whatever's here unless it's null, in which case I'll stop. So it's kind of a while loop. Make sense? All right. So that's literals. Just an overview of sorry, so I got to do a little bit more of this. So more examples. So here I said star PA is 0. I could actually use it for something more useful. So I can say something like PA is address of n. So and what this does is it says like the right-hand side is and then we just so we're going to be like that. So we're going to be over here. So let's look how that's what? Sorry. Yeah. So that's gonna look like this. So the ampersand means address of, and what's gonna happen? So here you'll notice that n is stored at this address. So the address is written kind of weirdly, but that's fine. So what's going to happen is we are taking the address where n is stored, so this guy, and we're storing it in PA. Okay, so that's what that does. We can now say and in this, so when on the right hand side, get the value at the address. So star PA so M now is going to be 25. So that's like this. So now what's going to happen is PA is this guy. And then saying star PA is saying, go to this guy and get me whatever is the value there, which is 25. So that means that the value of this is going to be 25, and that's what's going to get put in M. All right. So, okay, I think that's, yeah, so I think that's as far as we're going to get today. So this is how variable declaration works. So I can declare an int, there's long int, there's car star we saw, and you can declare a variable of type car star, so address of a character with %C. All right, I promise it will make sense by Thursday. I will see you. Bye. Thank you. Yeah, and yeah, just like trust me, for a few days, there's just like a lot of things going on at the same time. There's no way to disentangle them, but we'll get there.